Well, thank you, Taya. And just a big thank you first to the community. That includes the users who have been vocal and active in helping the developers and the engineers to create 0.6. The feedback loop is invaluable for us to provide the proper features that folks need in 0.6. So really excited to have the developers actually show their work today. I don't know why my presentation won't move forward. There we go. All right, now just a quick review of what we'll be going over. Hopefully everyone can see I'm on the feature review slide. We'll first talk about the priorities that were identified by users in the surveys and our standard customer user journey process. We'll talk about the major features that have been delivered, artifact tracking, the pipelines enhancements, the data versioning, customize, a multi-user authentication, and we'll go into the doc sprint. We'll provide an end user experience of a user that's already deployed 0.6, go over some 0.7 feature candidates and do some Q&A. From a priority standpoint, what we tried to do is identify the top 4 or 5 priorities that came in, and if we can simplify those into folks asking about on-premise and related to that, multi-user authentication, simplified installations, and simplified end-to-end workflows. People wanted it easier to set up infrastructure and to take models to production, to have iteration and tracking of experiments to be more comprehensive and easier, and then of course to help and have better documentation. So on the right here, you can see a kind of a green box, and we try to identify as we go through which features kind of flow into these themes. A little more detail from the user surveys. This shows the where do people run their ML workloads. You can see a good percentage of folks running on premise, with GCP and AWS being the next most popular. But kind of a nice slide here from the first quarter user survey. And I think these are valuable for us as we're doing analysis of where to invest time. Another piece from the 2Q user survey, which features authentication and authorization will folks need, and here we have a single sign-on and LDAP and AD integration being of the top requests, along with resource quotas and static passwords. So some interesting data here. And then what pain points are in your ML, your machine learning workflows today. Setting up infrastructure obviously looks to be number 1, taking models to production, and then iterating or tracking experiments. And of course, data cleaning and preparation is another one that is high up there. And then what improvements would you like to see in Kubeflow? On this simplified end-to-end workflows, obviously getting the products into production faster, better documentation, and simplified installation. So again, kind of reiterating the themes that we saw at the very beginning. And from user reviews, just a couple of notes here from Jeff Fogarty at US Bank. Again, multi-user functionality is a foundational building block, especially for on-prem. So exciting to get that type of feedback from users, and we invite that those comments from other folks. And Laura Shornack from City Scholars, who's a part of JP Morgan Chase and the University of Illinois. Data versioning allows us to snapshot data sets and recreate models quickly, and it simplifies workflows and improves productivity. So those are great feedback. And from there, I'd like to dive into some of the details. Zhengui, I believe you're going to take it from here, correct?
Yes. Thank you, Josh. I'll talk about artifact tracking. So as we all know, machine learning in practice is often an iterative process. And during this iterative process, it's very important to track all the experiments and artifacts used and produced in various experiments. So the long-term goal here is to track all the artifacts and experiments to enable reproducibility. So in Kubeflow v0.6, it ships a metadata component to support artifact tracking. The component consists of 3 parts. The first part is a backend service which manages a MySQL database to organize artifact information and also lineage information. The second part is a Python logging SDK, which allows the user to input artifact information into the backend. The third part is a web UI, which visualizes the artifact information. The metadata component also comes with a very flexible type system. So users can define their own artifact metadata type and store information with strong guarantees provided by a type system. To make the metadata component easy to use out of the box, we ship 3 predefined artifact types, namely the dataset, model, and the evaluation metrics. So in the next few slides, I will give more details about the logging SDK and the web UI. Next slide, please. In this slide, I'll show you a logging example. So on the left-hand side, it shows the code creates an execution context. So optionally, you can group the execution context into workspace or runs for easy search. And on the right-hand side, the code actually logs a model as an output of execution. If you look at the metadata.model, it's our predefined types with the information about the model version, model type, URI, and hyperparameters. As you can imagine, we can similarly log a dataset as the input to the execution and the evaluation metrics as the output. So we have the complete information about how the model is trained and how well the model performs. In the next few slides, I will quickly show you the UI. Next, thanks. In this UI, it shows the list of models with versions. This UI is part of the Kubeflow central dashboard. And all the artifacts logged from SDK will be shown here. And you can actually type in the box to search and filter the artifacts. So in the middle, it shows like models with 3 versions grouped together. And if you click one of the versions, you will go to the model details page. Next slide, please. So in this slide, it actually puts 3 model versions together. I highlighted the versions and its hyperparameters, so you can easily compare the models and how it is trained. Next slide, please. So this is a quick UI to show you we have a detailed page also for the dataset and the metrics. So you can find the information about where the dataset is stored and when it is created. So that's all about the overview of metadata component. I'll now hand over to Jessie to talk about pipelines.
Thank you, Zhengui. So on the pipeline front, first we will start with UI. So first of all, we've made big perf improvements on the page load. And so for example, like load list of runs, and the performance has been improved from magnitude of minutes to seconds. And it's primarily thanks to the backend API perf optimization. And the next 3 bullets is mostly about the new UI features that we enabled. So for the run creation, for logs, and for better visualization. And we actually have screenshots that we're gonna show the exact UI features in later slides. So we will go over that then. And TensorBoard instance is now being created via CID for the better reliability. And on doc and the sample site, we've added API documentation as well as the SDK. So the link here will actually bring you into the actual section on the Kubeflow website. So you can see the details there. And on the new samples, so right now we have categorized our samples into 2 classes. One is the core samples, and the second is the So for core samples, the plan is actually we will run core samples as part of pre-submit later on, like in this quarter. And the contribute is primarily basically it will not be run as pre-submit, but we will probably run that as a continuous integration passes. So now back to the exact ones that we added in this release. So AI platform pipeline, this one actually illustrates how to leverage existing AI platform services, in particular, training services and prediction services. And the second one, Auth Transformer, this is to demo on one of the new DSL features that we added in this release, which we will cover when we talk about DSL improvements. And the TFX taxi samples actually added support for on-premise, and it actually also explains how do you set it up to run on-prem. And the image captioning one, and this one illustrates how do you convert a TensorFlow notebook to Kubeflow pipeline using Jupyter Notebook. So next, please. So now we are going to show you the exact UI changes that we made. So this one is for streamlined run creation. So there's two features that we added for run creation. One is you can actually specify whether this is a one-off run or this is a recurring run on the UI. And second is experiments are not optional. So you can create runs without experiment, and it will be placed in the default experiment on UI. Next, please. So this one shows you the stack driver logs. You can see the links on the UI, which will point you to the actual GKE stack driver log. So one thing to point out, this feature is only enabled for GCP customers. Next, please. And this screenshot kind of shows you the metric UI alongside the run output tab. So you'll see like these metrics are now being displayed in this tab. And next, please. So this one is kind of relevant to the previous UI, but this allows you to compare the metrics across multiple runs. So it makes the visualization a lot easier for you to do the side-by-side comparison. Next, please. So the slides, we will cover all the DSL features that we added in this release. So first of all, we added TFX Kubeflow Runner, which enables the user to run TFX pipeline on Kubeflow. And we also added ability to do the CMLE training and the pushing. So two links here, there's user guide, which walks you through exactly there's example on how this is being done. And the RFC document here actually explains all the design details that behind the feature. The second is the preemptive instance support. So basically, this allows a user to run the pipeline with the preemptive VMs. And basically, the benefit here is for the cost perspective. And the third bullet talks about the Auth Transformer, which I briefly touched in earlier slide. So this is the one feature where it enables horizontal changes across all steps within the pipeline. And the link here shows you the example on how to apply the retry operations across all the steps in the pipeline. So this just serves as an example. And next bullet talks about the SDK feature parity to API. So we enabled delete, load, upload, and list all these server-side API calls through the KFP client. Next one, it talks about the timeout support, which is enabled at container op level as well as the pipeline level. So again, the link here, you will see the details of the PR change. And there should also be a sample that you can refer to. And then we also add a type check for default values, as well as exposing the build failure log. And the links here, again, points you to the exact PR so that you can get the details about. And there's also screenshots in the PR about what the actual failure log looks like at the output. So next, I'm gonna hand over to Constantinos from Arrikto to talk about the volume support in DSL.
Thank you very much, Jessie. So following our users' feedback, Kubeflow 0.6 extends the pipeline's domain-specific language, adding new primitives that enable data versioning in pipelines. Kubeflow pipelines now expose two new resources, a persistent volume and a volume snapshot. Both are integrated via standards-based Kubernetes PVC primitives, backed by the latest functionality of the container storage interface. And the new functionality essentially allows for immutably snapshotting data volumes after pipeline steps in a versioned way, and also enables for efficient exchange of multi-gigabyte data between steps without the need for uploading or downloading from external object stores. So as you can see in the example in the next slide, here is the official TFX taxi cab example, where we have augmented it with the new functionality that allows us to start the pipeline by creating, cloning a volume from an immutable snapshot, from an immutable PVC, feed that PVC to all other steps, and at the end of the pipeline, after the prediction and analysis steps are over, we are able to snapshot the data volume again in an immutable way, so we can either reproduce it later or feed it to a notebook to do further experimentation or debugging. Next slide, please. So here we see how easy are the new definitions for volume op and volume snapshot op. And in the next slide, we can see how simplified the code has become before 0.6 and after 0.6, when somebody wants to actually write in the DSL and work with volumes from over 10 lines before to 3 lines and without importing the Kubernetes client at all. And with that, I will hand it off to Kam to talk about the great effort introducing Customize.
Thank you. Yeah, so Customize was a feature that we moved in beginning in 0.5. We did used to use KSonnet, and KSonnet effort was archived. So we decided, if you go to the link on the bottom with some rationalization, why to move to Customize. And in 0.6, we now have Customize as the default package manager. We moved all of the KSonnet libraries over to a separate repro under Kubeflow manifests. And beginning in 0.5, this was a joint effort with Intel and Cisco and IBM and Arrikto. And it required some serious replumbing of KF-Coddle and a lot of movement of the different KSonnet libraries over to this new repro called Manifests. And during this move, we've driven some changes within Customize, and we have initially gone to Customize 2.0.3, and we will move in the next release over to 3+ for Customize. And we find that it's been a great utility. It's integrated into kubectl as a plugin. In 3+, they allow more powerful types of plugins. So we're excited and looking forward to additional Customize features we'll introduce. And I will now hand it over to Yannis to use KSonnet, and KSonnet effort was archived. So we decided, if you go to the link on the bottom with some rationalization, why to move to customize. And in 0.6, we now have customize as the default package manager. We moved all of the KSonnet libraries over to a separate repro under Kubeflow manifests. And beginning in 0.5, this was a joint effort with Intel and Cisco and IBM and Arrikto. And it required some serious replumbing of KF-Coddle and a lot of movement of the different KSonnet libraries over to this new repro called Manifests. And during this move, we've driven some changes within Customize, and we have initially gone to Customize 2.0.3, and we will move in the next release over to 3+ for Customize. And we find that it's been a great utility. It's integrated into KubeCoddle as a plugin in 3+. They allow more powerful types of plugins. So we're excited and looking forward to additional customized features we'll introduce. And I will now hand it over to Yannis.
With Kubeflow 0.6 comes the initial support for multi-user workflows. And we want users to be able to work in their own isolated environment, and we have started doing that with notebooks. The initial support for multi-tenancy in the form of notebook isolation is currently available for GCP, and for on-prem and non-GCP environments, we have designed and implemented a proposed architecture using Istio and Dex, which users can connect to their own LDAP or Active Directory server or external identity provider. And authorization will also soon be available for on-prem environments once we remove some hard-coded GCP values from the code base. All right. So next slide. In the next slide, we see an architecture overview of our vision for the Kubeflow multi-tenancy. The main units of isolations are profiles. A profile is a wrapper around a namespace and permission object. A profile can be private, for example, belonging to a user, or a profile can be shared, for example, belonging to a team. For now, only Kubeflow notebooks support multi-user workflows, but in the future, more and more components will support this kind of model. Now I will hand it over to Kunming, who will talk about this implementation and effort in more details.
Hi, everyone. So Kubeflow multi-tenancy new features. So why we need to implement this Kubeflow multi-tenancy support? So as we all know that the Kubernetes resources by default is transparent within the clusters, so everybody can access every services in the clusters. And by default, we cannot identify access control who can access what resources in fine-grained levels easily. So the first feature we're gonna support is isolated Kubernetes resources based on namespaces, and the resource owners, like notebook authors, can control access of the resource they own, can control who can access their code or data. The second feature we want to support is for the resource owners, they can easily share and revoke access to their notebooks, data. So we will automatically update the Kubernetes RBAC policies and Istio RBAC policies so that users share and access and revoke access actions will be applied to both places, both RBAC policies. And third, Kubeflow multi-tenancy implementation is like a purely Kubernetes native, so it's easy to be integrated and really lightweight. And finally, in Kubeflow 0.6 release, we will add a new UIs to support all the access control features to simplify the experience. Next slide, please. Yeah, here we show how to integrate. So to control the access for every UI request from users, we need to know the identity of the user who makes the request, right? So we need to make sure that the identity in UI request and in CLI request are the same. So for cloud users, for example, Google Cloud, public cloud provide a cloud identity proxy service, which if you configure it to make the request through the cloud identity proxy service, every coming request from browser will carry user's identity. If it's on-prem case, you can set up the OIDC auth plus DEX in front of EC2 gateway. So on both cases, EC2 gateway will receive the request with the identity inserted in request. So it can be consistent with the kubectl CLI request. So every request has the identity inside it. Next slide, please. So now we talk about the both requests, how the policy affect the access control. So all Kubeflow applications together with profile CRs, KFM APIs is controlled under Kubeflow application grouped under Kubeflow application CR. So we use unified profile policies to edit both EC2 RBAC and Kubernetes RBAC. So when users, for example, when users make share access to one user, both policies are updated. So that means for that user, instantly they have access through either browser request or kubectl request. So for browser request, like we said, EC2 gateway receive the request, get the user identity, and going through EC2 service mesh. Service mesh will consume the policies and decide if they will allow or deny the access to the Kubeflow services. If it's a kubectl access, the access directly going through Kubernetes RBAC and finally reach the Kubernetes masters, which will consume the Kubernetes RBAC policies and allow or deny the access to Kubeflow services directly. Can go to the next slide. This one's on-prem architecture. I will hand back to Yannis.
Thank you, Kunming. So this diagram details the proposed architecture for vendor-neutral authentication and authorization in Kubeflow, and this is particularly useful in on-prem situations where you don't have access to cloud-specific services. This architecture uses Istio to enforce authentication for all incoming requests. To authenticate the users, we use the OIDC flow with DEX as an identity provider. And DEX supports multiple backends for authentication, including LDAP, static users, and external identity providers. So this makes a very flexible and extensible solution. If you want more details about how this architecture was designed and implemented, please check out the links in the slide. And please test the initial support for multi-users in Kubeflow and give us feedback on how we can improve and move forward. Now I will hand it over to Josh to talk about the doc sprint.
All right. Well, thank you, Yannis. The doc sprint was a fantastic effort set up by and run by Sarah Maddox. And just can't say enough about how important it is that both users and contributors help in improving the documentation. You can see here, lots of pull requests merged and closed. There's a full blog post on this. But quite a great showing from users like JP Morgan or other contributors, whether it's Canonical, Agile, Stacks, Microsoft, Google, or Arrikto. The 3-day event that was held in Kirkland, I think, was really valuable, and do appreciate Sarah's and Michelle Caspon's work to really get that on track and keep it moving forward. So great work there. Hold on for 1 second. Yeah, so the next slide kind of shows some of the details, including, you know, how to improve the getting started, the metadata, and the Docker calling out, you know, the reference table on the Docker files, which I believe the JP Morgan folks contribute. That was great. Lots of work on documenting authentication and on-prem configurations. And then again, more tutorials and work on helping people understand pipelines. So a lot of good work here, a lot of good reading for folks. With that, I'd like to hand off to Jeremy, excuse me, Jeff Fogarty from US Bank to talk about his experience with Kubeflow 0.6 in an on-prem environment. Jeff?
Yeah, thanks, Josh. So yeah, thanks to Arrikto's help, we worked through the install. It was very painless. So here, the slide you see, here's the vitals for what we did. It's a 3-node cluster. The AD authentication is working really well. Notebook isolation. And you can go to the next slide. Yeah, the storage is working well. So we've been working through some test cases. The pipelines is coming along. We've ran through a couple tests, and the version of the notebooks is really good. It's going to be very helpful going forward. I also been able to create some virtual services for Kiali and Grafana, and working through some getting more configured there. But the on-prem was really helpful to have Arrikto help us with that install. So from there, back to Jeremy, I believe.
Great, thank you so much, Jeff. So we just wanted to give you some statistics about the 0.6 release. So I think, you know, the first thing to note is that we're continuing to maintain our quarterly release schedule. So the 0.6 release represents our Q2 release. And then we will be doing another release at the end of Q3, which will be 0.7. And then you can see some statistics about the 0.6 release. We have over 216 issues closed, which is really impressive. I think even more impressive is the number of PRs, number of PR creators. So we had over 150 unique PR creators, which is really impressive and awesome, and shows how quickly we are growing as a community. And you can actually see with the graphs on the right, the trend since the beginning of Kubeflow. You can see that we're continuing to grow pretty rapidly in both the number of PRs that we get every 28 days, as well as the number of unique PR creators every 28 days. And then next slide. So with 0.6 under our belt, we're headed into 0.7 in the next quarter. And so I think one of the big pushes for 0.7 is just getting to getting ready for Kubeflow 1.0, which we're going to try to get done by the end of the year. It's a pretty ambitious goal, but that's what we're shooting for. And so really what that means in 0.7 is that we're focusing on trying to graduate a lot of the functionality that we have to beta quality, with the goal of getting it to 1.0 quality in Q4. So some examples are listed on the slide. So as an example, we want to get KF-Cuddle, which is our deployment tooling, to beta quality. We want to get all of our Jupyter infrastructure to beta quality. We want to introduce upgrade functionality. We know that's been a huge pain point for our users who want to upgrade between major releases. So we're really keen to get that into our next release and provide an upgrade path from 0.6 to 0.7. We also intend to provide better improve our multi-user support, basically adding more applications that integrate well with our multi-user story. We're continuing. A big push for us in 0.7 is also going to be improving the data science experience. So we want to continue to make it easy for data scientists to leverage accelerators and custom hardware. We want to make it easier for data scientists to monitor their training jobs and model deployments using applications like TensorBoard. We want to continue to improve the data story in Kubeflow. So we want to provide an application that makes it easy to manage persistent volumes so they can more easily move data across different parts of their workload, from like training to prediction, for example. Metadata is a huge focus in 0.7, so we want to continue to build on what we launched in 0.6. And so in particular, we want to get more metadata integration into our existing applications like TensorBoard and Katib. And then we'd also like to begin automatically logging data to metadata. So we'd like to automatically ingest a lot of your Kubernetes resources and turn that into metadata for you so you don't have to think about it. And so the next slide, please. And so finally, we are an open community, so please do join us if you would like. So you can join us at the Kubeflow Slack channel. It's a public channel. You just need to get an invite at the link in the slides. You can also join our Kubeflow Discuss mailing list. And then we have our weekly community meetings. And you can find those calendars on the kubeflow.org website. And finally, we would love it if people try out Kubeflow and let us know about any issues or features you would like to have. And I think with that, we're going to go ahead and do Q&A.